We learn Cartesian, remember that? The second one's called what? Path. What's your favorite? Well, polar, yep. Are we all great? That's your favorite coordinate system? Okay. Without looking at your notes, let's see if we can kind of finish up this table, just as a recall, review. For positions under Cartesian coordinate system, it's pretty easy, right? R equals xi plus yj. Under Cartesian coordinate system, the velocity v equals x dot I plus y dot j. For A, it's just x double dot plus y double dot. Pretty easy for Cartesian coordinate system. And for path coordinate system, things are getting a little bit crazier. Do we have a position vector? What's a position vector for path coordinate system? No, we don't have one. Let's cross that. But we do have a velocity equation, which is v times e. E is the unit vector. Should that be et or en? Et, yes, et hat. That's the velocity vector under path coordinate system. Now we have acceleration for path coordinate system. That is v dot et plus v squared over rho en hat. Okay. Those are the two equations under path coordinate system. Now I have a question for you. What's the name for v dot? Mentioned they have a rate change of speed. Yes. If you don't have that on your notes, write it down. That's the name for that v dot. If you ever heard that name, rate change of speed, that's kind of begging you, okay, this is path coordinate system. Please use path coordinate system. What does this rho represent for? Rho, it's radius of curvature. Okay, write that down if you don't have that on your notes. Okay, that's all about path coordinate system. Now let's talk about polar. What's the position vector under polar coordinate system? For polar coordinate system, the position is r, which is the radius from origin to the particle, times e, should that be er or e theta hat? Er. Okay, that's for position. For velocity, anybody remember the equation? It's pretty hard. For this, you can check your notes. I couldn't even remember what that equation is. I need to check mine. Okay, for V, we have R dot ER hat plus R theta dot E theta hat. That's for velocity. For acceleration, you have that long, crazy equation. For acceleration, we have R double dot minus R theta dot square. That's for your ER hat component. We need plus R theta double dot plus 2 R dot theta dot E theta. That's for acceleration. Okay, those are all the equations we learned last week. And everything are inside of this table now. Now let's look at drawings. Since you need to draw the unit vectors for all your homework problems. For example, we have this particle P, it's moving the same particle P. Now let's try your best to draw the unit vectors for those three, all the same particles under different coordinate system. Give you like 1 minute to try draw both unit vectors for each particle. And I will draw here so you can compare yours with mine. Oops. Okay, this is how I would draw the unit vectors for the same particle. Cartesian should be pretty straightforward. Path coordinate system, always keep that in mind. ET must point into the motion of, the direction of motion of the particle. And EN is pointing to the center of the curvature. That's for the path coordinate system. Those two directions are very important. Keep that in mind. For polar coordinate system, you can pick any origin you want. And ER, it's a unit vector pointing from origin to the particle. And E theta, it's a unit vector that's pointing to the increasing angle of theta. Theta is this angle here. It's increasing that way. So E theta is pointing to that direction. Okay, so that could be, now we have everything we learned in last week. Equations and how to draw the unit vectors on a moving particle. Any questions before we move on to our examples? Of course, this one looks like the hardest one, right? More complicated. We'll see that. We're going to do example for polar coordinate system. All right, now I want you to take off your textbook and turn to example 1A3. I need a volunteer. Sean, right? Do you mind read this for the rest of us? Oh, sorry, we did 1A3, right? Okay, my bad, it's 1A4.
Particle A travels on a path such that the radial position of A is given by R, the spot right there. where R is given in meters, theta in radians. It is also known that theta equals 2 rads, which equals a constant. Determine the velocity vector for A when theta equals pi, and the acceleration vector for A when theta equals pi.
Okay, thank you. All right, so for this problem, same thing for your homeworks. Have the given, have the fun, and draw the figures. Here for given conditions, we have R, which is the radius. It's given as a function of theta, R equals 5 theta. And theta is given, theta dot, it's given as a number value, 2 radius per second, and which is a constant. So whenever you see the word constant, I would just put that constant right after that value to remind myself that is a constant. So theta dot is a constant. What we need to find are velocity of A at a certain angle when theta equals pi. Also need to find acceleration of A at the same angle, theta equals pi. Now, just look at all the things we know. Which coordinate system you want to use. And keep that in mind for this section. That's the first question you need to ask yourself. What coordinate system I want to use for this problem? Do you want to use, if you want to use Cartesian coordinate system, raise your hand. Any path coordinate system, raise your hand. How about polar coordinate system, raise your hand. Yeah, this is pretty obvious. The reason we want to use polar coordinate system, that's because we see a lot of thetas, right? Where do you see thetas? You only saw thetas in under polar coordinate system. Where do you see R? Only in polar coordinate system. So that's kind of give you a hint. Yeah, theta, we have R, polar coordinate system makes sense. All right, if we want to use polar coordinate system, that's, of course, we want to use the velocity equation, acceleration equation. So that's first just copy down what is the velocity equation for polar coordinate system. So we want to use polar. And the equation for polar, it's r dot er plus r theta dot e theta. We know the equations. And so if we know what is r dot, what is r, what is theta, we will have the answer. Right? That's how straightforward it is. And so next task for you is to find out what is r dot. What is r and theta dot? I think r and theta dot are very straightforward. It's given right there in the given conditions. And the question is, what is r dot? R dot. How to find r dot? Let's come back to the given. We know r is 5 theta. Dot means first order derivative with respect to time, right? So we can take dr over dt. That should give us r dot. If we know r equals 5 theta, what is dr over dt going to be? What is the answer here? What is r dot? Go ahead. 5 theta dot. Yeah, that's it. It's pretty not too hard. 5 theta dot. Okay. So now we know what is r dot. Here is just another question for you. What is r double dot? Just curious. So it's just, you take 5 theta dot dt. What's the result of that? Anybody know answers for r double dot? We already know what is r single dot. It's 5 theta dot. What happens if you take one more dot? Don't worry, we got the wrong answer. Anybody knows? Should be 5 theta double dot, yeah, right? Okay. So this is not too bad just for what we have here when r equals 5 theta. But what happens if now I change this little bit? Imagine this is the same example. Well, at this point, we know at 5 theta, plug this in, you get the answer for this problem. Imagine if I use the same problem for your exam, but I changed one thing. Now, if I use r equals 5 theta squared, now I want you to find out what is r dot, what is r double dot. There's a high chance this will be on your exam. Okay, what happens if we know r equals 5 theta squared? The only thing difference is I add a square over there. How would that change your r dot and r double dot? Give you a hint. It's go back to review. What is product rule you learned? Which is important to solve this. Go back home to review product rule. But now I can tell you the answer. So r dot is going to be 2 times 5 times theta times theta dot. How many of you got that right? Okay, give you 1 minute to try r double dot. Let's see how many of you got that right. Try that on your notes to see if you can get r double dot. Remember product rule. Okay, the r double dot is 2 times 5 times r dot square plus 2 times 5 times theta times theta double dot. Raise your hand if you get something like this. Okay. Yeah, this is the tricky part. Since it's not dynamics, is from your calculus. I don't know which course is that. If you don't know what the heck is happening here, and feel free to go back after class, check product rule, and do some practice. And if you still don't know, come to my office hours. All right, I can help you with that. All right, so that's something you want to do after class, figure out this. All right, now let's keep moving. Let's come back to this example. We want to find the velocity. We know all the components inside of this equation. R dot, it's right here, 5 theta dot. So we can write that down. Uh-oh, add that question. Okay, we're good. So 5 theta dot ER plus 5 theta times theta dot E theta. Now what we end up with is this. You plug in what is theta dot. Theta dot is given. Once again, theta dot is 2 radians per second, which is a constant. So you plug in theta dot, which is 2. You end up with 10 ER hat plus 10 pi. Where does that pi come from? That is given for this problem. We're looking for the velocity and the acceleration at theta equals pi. That's why you plug in pi, theta for pi. And for your homework problem, you need to write your homeworks, right? I want you to highlight or box your final result. This. Make sure you, since we are talking about velocity here, make sure you have the proper units. And of course, we're in this class, we use vectors a lot. So make sure you have the vector notations. Also your both R component and E theta components. This is how we solve velocity. Any questions? Now let's follow the same drill for acceleration. First, we can copy what is the acceleration equation under polar coordinate system. It's that very long equation. Okay. And if let's look at what's inside of this acceleration equation. In order to find out what is acceleration, we need to find out what is R double dot. I think we just did that, right? In the practice, R double dot is 5 theta double dot. And we know what is R, we know theta dot, we know R. Theta double dot is not given directly. What is theta double dot? Let's go back to given condition. Theta dot is 2 radians per second and it's constant. What is theta double dot? What? I hear some answers. 0, yes, that's right. It's 0. If you take a derivative of a constant, you get 0, right? So R double dot, it's 0. And we know this guy, which is 0. 2, R dot. I think we know R dot. No, we don't know R dot, but we just did the practice on R dot. And theta dot is given. So plugging everything into this equation, you should get 5 times theta double dot minus 5 theta times theta dot square ER plus 5 theta double dot plus 2 times 5 times theta dot E theta. And plugging all the theta dot, theta double dot, so many dots here, you will end up with expression for acceleration, which is negative 220 pi ER hat plus 40 E theta hat. Meters per second square. Okay. Yeah, the polar coordinate system has a longer, much larger equation for velocity and acceleration, but the process is just plugging all the things you know into the equation. Yeah, any questions? So far we solved this example for A and V. Questions?
Isn't the acceleration like equation? Isn't that a double dot on the square one?
This one?
Yeah.
It's single dot. Yeah, if you go back, check the equation, it should be just a single dot square. So let me talk, I could never remember this long equation. So every single time I would go back to check textbook, make sure I got exactly the right equation. I want you to do that too. Don't guess. I think that's a double dot. No, go back, check your book, all your notes. All right. Let's move on to our next example. That's example 1A1. I will need a volunteer to read this problem for the rest of us. Who has a book? Okay. Do we have a volunteer who want to read? Okay. Okay. Excuse me, what's your name? Taylor, do you mind read this problem to the rest of us?
MP is constrained to move along an elliptical length. The shape is given by x squared over a squared plus y squared over b squared equals 1. The shape is also constrained to move within a horizontal slot that speed of v. Determine the velocity of MP at the position corresponding to y equals 6 millimeters, and the acceleration at v at the position corresponding to y equals 6 millimeters. Use the following parameters in the analysis. A equals 5 millimeters, B equals 10 millimeters, B equals 30 millimeters.
Thank you. So in this problem, we have a plane P. And treat that as a moving particle. And this particle can only move along that ring and also along that horizontal slot. And that slot is connected with a column that can only move on y direction with velocity v, with a speed v equals 30 millimeters per second. And we know the mathematical expression for that shape is x squared over 2 plus y squared over b squared equals 1. Let me write down all the given conditions here. square over a square. We know A equals 10 millimeter. Oh, sorry, that's 5 millimeters. B equals 10 millimeters. And speed of that color is moving at 30 millimeter per second up in that direction, which is a constant. We want to find out what is the particle P is moving with velocity of P at y equals 6 millimeter. So what is the acceleration of P at the same y? Okay, that's everything we know about this problem. What's the first question you want to ask yourself? What's the question you should ask yourself first before we start this problem? What we did, what was the first step we did for the last example? Yeah, what coordinate system we want to use? Do we see theta and r's in this problem? Any theta and r's in the given problem, given conditions? No, we don't see any. So we probably don't want to use polar, right? You can, feel free to do so, but that would make your life much difficult if you do that. Right, so no polars. Are we all gray? You don't want to use polar. How about path? What are the things unique to path? Rate change of speed. Do we have anything about rate change of speed here? We only know velocity of speed, but that's not a rate change of speed. Do we have radius of curvature here? No. Okay, that only leaves us one option, which is Cartesian coordinate system. Okay. So let's use Cartesian coordinate system. Since we want to find out what is the velocity and acceleration, and let's just go back to the table we just did at the beginning of the class, find out what's the equation for velocity and acceleration under Cartesian coordinate system. For velocity, the equation is xp dot I plus yp dot j. For acceleration, we have xp double dot plus yp double dot j. Oops. This. So now we know the equations to solve velocity and acceleration. And the equation tells us if we know xp dot, yp dot, we should be able to solve velocity. But do we know xp dot or yp dot? Let's come back to the given condition. There's nothing tell you what is y dot, x dot. Something very close is we know this expression. Can we find out x dot p dot from here? We have x and y here. How to find x dot p, y dot? Dot means just time derivative, right? Why not? Let's just do a time derivative of this expression, this whole expression. Do it for both sides of equation. Time derivative for this side of equation another time derivative on this side of the equation, and the equation still holds equal to each other. And just one question. Here's one. What happens if you do a time derivative for one with respect to time? 0. Yeah. Okay. So that's kind of the logic. We want to find x dot y dot by doing derivative for this expression. So we want to do this d dt is x squared over a squared plus y squared over b squared. This is the left hand side of the equation. And for the right hand side, we have like we said, you take the derivative of 1 will give you 0. For the left hand side, let's see if we can use distribution rule to look at the first component first, plus the y squared over b squared dt. So make our life a little bit easier. Instead of looking at the whole thing and take derivative, now let's just look at what's the time derivative of just this guy, x squared over a squared. Give you 1 minute, try your best to see if you can get a time derivative of this expression. Okay, I will write my answer here. So the time derivative of x squared over 2a squared is 2 over a squared times x dot. Any question here? Take the derivative of, well, a squared is a constant, so you don't have to concern about a squared. Just leave that as it is. And this 2 is come from the power of x. Then that become, after you use 2 minus 1, that will give you just x. Now you need to consider x is a variable of time. So you need to take times x dot. That's a complete correct result for the time derivative. Well, since we already have this, you can apply the same rule for this expression, y squared over b squared, right? You can just guess the answer should be 2 over b squared times y dot. And 0. Okay, oops, sorry, I made a mistake here. Y dot. All right, now we have something with x dot and y dot. We're pretty close to what we want. Just want to keep you, remind you, the goal is to find out what is x dot, y dot, so that we can plug in that into this equation to get what is velocity. Now, at this point, we have this expression with x dot and y dot. So that's why we are pretty close. And x and y's are the positions. Seems like, do we know anything about x and y's in this problem? If you go back to the find, we want to find out what is xp and ap at y equals 6 millimeter. What is that? That tells us y, the value of y. If we know the location of y, do we know the value of x? No or yes? The pin can only move along this range. Now we know y equals 6 millimeters. It's on probably around here. Do we know anything about x? What happens if you plug in y equals 6 millimeters into this equation? You should find two values of x. X equals positive or negative something, right? And that tells you the value of x. So let's go back here. So you can treat, we know what is x, we know what is y. A and b are given. And x dot is something we're trying to find. Y dot. What is y dot? Y is a position vertical direction. Y dot, it's a what? Take the derivative of position, that is speed, velocity, right? Speed and velocity. And do we know anything about the speed on y direction? Do we know anything about speed on y direction? What is this guy, v? What is v? If you have a textbook, you can read what is v. V is the speed of that color moving on y direction, right? So v, this is v here. V is the direction, the speed on y direction only. It's the speed of v. What's the relationship between the speed of v and particle, the speed of particle at that point? So the particle is moving along this range. It probably has an x component and y component for its velocity. And so I'm not sure if you can see that the y component of velocity of particle p should equal to how fast this color is moving. There, right? This particle p is kind of, it's controlled on y direction by this color, how fast it's moving. So that tells us the y dot. Very important information about y dot. This y dot here, it's a speed of y direction, on y direction, which is 330 millimeters per second, which is one of the given information, given condition. In that case, x dot is our only unknown. We can find x dot as negative a squared y b squared x times v by replacing y dot with v. Now we have expression for x dot. So like I said, we know the value for y, which is 6 millimeter. When you plug in y equals 6, you can find out x equals positive, negative a squared 1 minus y squared over b squared. We'll end up with positive or negative 4 millimeters. Then you have to make a decision, should that be positive 4 or negative 4? That depends on the drawing of this problem. If you go back to the drawings and you realize particle P can only move on the negative side of x direction. When y equals 6 millimeters, somewhere around here, there are two possible points on this ring. One is right here, one is on this side. Particle P can only on the negative side of x. That's why we take negative 4 millimeters. X equals negative 4 millimeters. And now we have values for y and x. We have the expression for x dot. And you can plug in y and x to that expression. You can find out what is the value for x dot. X dot equals 11.25 millimeters per second. Okay, so now we have x dot and y dot, which is v, which is 30 millimeters per second. We can plug in both x dot, y dot into the expression, into the equation to find out velocity, which is 11.25 I plus 30 J. And the unit is millimeters per second. Okay. Let's kind of review what we did. We first decide which coordinate system we want to use. We picked Cartesian. Then we identify the equations for Cartesian coordinate system. For velocity, we have Cartesian equals v equals xi j plus y dot, no, sorry, x dot I plus y dot j. And we go through the big deal, a lot of things, try to find what is x dot and y dot. And once we find x dot, y dot, plug them into the equation, you get the quick result for velocity. And next time we're going to spend probably less than 5 minutes to do the acceleration, and then we'll be done with section 1AB. All right. I will see you guys on Wednesday. Remember, I have office hours today, at least from 1 to 2, and feel free to join the Zoom meeting to ask me any questions you want.